name is Hao Tianqian. In this video, I'm going to explain the main web development ideas we learned before the midterm. The title of my video is From Static Web Pages to Full Stack Applications. I chose this title because it shows the path of the course. We started with simple web pages using HTML and CSS. Then we added the Bootstrap and the JS. After that, we learned Node.js and Express. Finally, we connect the server to MongoDB so the application could save and load real data. The main question for this video is what happens after a user clicks a button on a web application. I will use this question to connect all the topics together. So here is the plan for this video. First, I will show the big picture of the concept map. This is my simple mental model for the course. Second, I will quickly explain the main topics we learned, including HTML, CSS, Bootstrap, JavaScript, the DOM, events, JSON, Node.json, Express, MongoDB, and some development tools. Third, I will go deeper in one topic, how data moves through a full-stack web application. I will also use a simple idea called the request passport. It is a small example that helps us follow data as it moves from the browser to the server, to the database, and back to the page. So this is my concept map for the whole course. I think of a map application as 5 connected layers. The first layer is structure. This is HTML. HTML tells the browser what is on the page, such as headings, paragraphs, images, forms, and buttons. The second layer is style. This is CSS and Bootstrap. This layer controls the things like colors, spacing, layout, and the responsive design. The third layer is behavior. This is JavaScript in the browser. JavaScript responds to user actions. It can read the page, change the page, and send requests. The fourth layer is the server. We use Node.js and Express for this layer. Node let JavaScript run outside the browser. Express help us receive requests and send a response. The fifth layer is the database. We use MongoDB to store information. The database gives the application memory, so the data does not disappear after the page reloads. We also use tools around these layers. GitHub helps us save and share the code. ESLint and Prettier help keep the code clean. Docker can help us run MongoDB on our computer. So before the midterms, the course can be divided into 4 main parts. The first part is the HTML and the CSS. We learn how to set up a web page, use different HTML tags, build a basic listing page, and style it with CSS. We also learn the box model and how CSS rules can conflict with each other. The second part is Bootstrap and JavaScript. We learn how Bootstrap gives us ready-made layouts and components. We also started using JavaScript and learned how to organize a project on GitHub. The third part is Node.js. We learned about Closure, JavaScript modules, Node.js, Express, and how a server can send static HTML files. The fourth part is Express and MongoDB. We learned routes, data endpoints, fetch requests, Docker, connecting Express to MongoDB, creating sample data, and reading data from the database. These are not separate topics, and each of them is one piece of the same full-stack application. So now I will give a quick explanation of the main concepts. I will start with HTML and CSS. HTML gives the pages its content and structure. For example, a workout website may have a title, a search box, a form, some buttons, and a list of workout cards. HTML answers the question, what is on the page? So CSS controls how the page looks. It changes the colors, fonts, spacing, size, and layout. It also helps the page work on different screen size. One important CSS idea is a box model. The browser treats every element like a box. The box has content in the middle, then padding, then a border, and then margin on the outside. When spacing looks wrong, the box model is often the first thing to check. Another idea is a CSS conflict. Sometimes two rules try to style the same element. The browser must choose which rule wins. It looks at things like specificity and the order of the rules. Bootstrap is a tool built on the top of CSS. It gives us ready-made classes and components. For example, Bootstrap gives us a grid system for rows and columns. It also gives us common components such as cards, buttons, forms, and navigation bars. Bootstrap also makes responsive design easier. We can change how a page looks on a phone, tablet, or desktop by using Bootstrap classes. But Bootstrap does not replace HTML and CSS. It still uses HTML and CSS underneath. Knowing the basics helps us understand what Bootstrap is doing. Next is JavaScript in the browser. JavaScript makes the page interactive. A very important idea is DOM. DOM means Document Object Model. The browser turns the HTML page into a tree of JavaScript objects. Because of DOM, JavaScript can find an element, change its text, create a new card, remove an item, and or add a CSS class. Another important idea is events. An event is something that happens on the page. The user may click a button, type into an input, or submit a form. JavaScript can listen for that event and run a function. We also use JSON. JSON is a simple format for storing and sending data. It looks a lot like a JavaScript object. For example, a workout page can have a name, a description, and a list of exercise. So a common browser flow is a user does something, an event runs, JavaScript reads the DOM, and then JavaScript changes the page or sends the data to the server. So as a JavaScript project gets bigger, we need better ways to organize the code. A closure means that a function can remember variables from the place where it was created. This is useful when a function runs later. For example, an event handler can still remember information that was available when we created it. Modules help us split code into different files. One file can export a function, and another file can import and use it. For example, one file can handle dark mode, another file can render cards, another file can send fetch requests. Modules make a project easier to read, test, and maintain. This is just like the object-oriented design. So now we move from JavaScript in the browser to JavaScript on the server. Node.js is a JavaScript runtime. It allows us to run JavaScript outside the browser. With Node.js, we can build a server. Express is a framework that runs with Node.js. It makes server development easier. With Express, we can create routes and endpoints. A route tells the server what to do when it receives a request for a certain URL. Express can also serve like static files. Static files are our HTML, CSS images, and browser JavaScript files. The main difference is simple. Browser JavaScript controls the web page, and server JavaScript receives the requests, works with data, and sends a response. They use the same language, but they run in different platform. So the front-ended and the backend communicates through HTTP. In the browser, we often use fetch to send a HTTP request, a GET request reads data, a POST request creates data, a PUT request updates data, a delete request removes data. Express receives the request at an endpoint, it does some work, and then it sends a response back. A response is often JSON. This is a bridge between the front end and the back end. The front end does not directly open the database. Instead, it asks the Express server for data. The server talks to database and returns the result. MongoDB gives us application persistent storage. Persistent means the data can stay there after the page reloads or the server restarts. MongoDB stores documents inside the collections. A document is similar to a JavaScript object or JSON data. For example, one workout document can have a name, description, and an exercise list, and ID. Inside an express route, we can use MongoDB Node.js driver. The driver lets the server connect to MongoDB, search for documents, add documents, update them, and or delete them. We also used several development tools. Docker can run MongoDB in a consistent environment. ESLint helps find the possible code problems. Prettier automatically formats the code. GitHub saves the project history and helps people work together. A README explains what the project does and how to run it. So basically, that's a walkthrough. Here's a summary. HTML answers what is on the page. CSS and Bootstrap answer how does the page look. And JavaScript answers what happens when the user interacts. The DOM and the events help JavaScript read and change the page. Fetch and TTP answers how does the browser talk to the server. Express answers how does the server handle a request. MongoDB is using to answer where is the data stored. Development tools helps us build, run, format, and share the project. All of these ideas work together, and the connection between them is the request and the response cycle. So now I will go deeper into one concept, the journey of data through a full-stack web application. I chose this topic because it connects almost everything in this course. A user action creates data. A JavaScript reads the data from the page. JavaScript puts it into an object. The object gets turned into JSON and sending an HTTP request. Express receives the request. The server may check the data and run a database operation. MongoDB stores or returns a document. Express sends a JSON response back to the browser. And finally, browser JavaScript updates the DOM so the user can see the result. A full-stack application is really a system of requests and responses. The user only sees buttons, but that button can start a process through every layer of the application. So let us use one simple example. The user creates a workout plan called leg day. So the step 1 will be the user types leg day into a HTML input field, and step 2, JavaScript finds the input through a DOM and reads its value. And step 3, JavaScript use fetch to send a post request. The request body contains JSON with a workout time. And then Express receives the request as an endpoint, such as a post/API/workouts. And then the Express route use MongoDB driver to insert a new workout document into a collection. And step 6 will be express sends a JSON response back to the browser. The response may include saved workout and its new ID. After that, browser JavaScript reads the response and updates the DOM. It may add a new workout card to the page. And finally, the user can see the lag day on the screen. One click has gone through the front end, the server, the database, and back to the front end. So let us look more closely at the HTTP request. A request usually has four main parts: a method, a URL, headers, and sometimes a body. The method says what action we want. Get means read, post means create, put means update, and delete means remove. The URL says which resource we are working with. For example, /API/workouts means the request is about work data. Headers give extra information. A common header is content type. Application/JSON. This tells the server that the request body contains JSON. The body contains the actual data. In this example, it may contain the name like leg day and a short description. In Express, REQ means request and RES means response. REQ body gives us the data from the request body. REQ parameters gives us values inside the URL. REQ query gives us value after the question mark in the URL. RES-JSON sends JSON back to the browser. These small pieces are the basic language of an Express API. So basically, I imagine the data as a traveler. Every time it enters a new part of the application, it gets a new passport stamp. So first, the data is plain text in an output in an input. When JavaScript reads it from the DOM, it gets a browser stamp. When fetch sends it to Express, it gets the HTTP stamp. When Express saves it in MongoDB, it gets a database stamp. When it returns JSON, it gets a response stamp. Finally, when JavaScript creates a new card, it gets the DOM stamp again. The idea helps me remember the information is still the same, but its form changed during the trip. So like it starts as text, then it becomes a JavaScript object, then it becomes JSON, then it becomes a MongoDB document, and it returns as JSON, and finally becomes something visible on the page. That is the main idea of a full-stack web application. Data moves through connected layers, and every layer has a different job. So for my live coding demonstration, I create a small workout planner using HTML and JavaScript. The demonstration does not use a server or database. The goal is to show how JavaScript can read user input, respond to events, store temporary data, and update the DOM. On the page, I have the text input for the workout name, select the menu for the workout level, and a button for adding a workout. The HTML is already prepared, so I will focus mainly on the JavaScript logic. First, I will quickly explain the HTML structure. This form has the ID workout form. Inside the form, I have one input for the workout name and one select the element for the workout level. The button has the type submit, so clicking it will submit the form. Below the form, I have an empty division with the ID workout list. JavaScript will use empty div as a container for workout cards. At the bottom of HTML file, I connect the page with app.js. So first, I create a empty array called workouts. This array will store all of the workout objects because this demonstration does not use a database. The array only stores the data temporarily in browser memory. If I refresh the page, the data will disappear. So next, I use document query selector to select the elements from the DOM. The form variable represents the HTML form. The name input variable represents the text input. The level input variable represents the select menu. The workout list variable represents the empty container where the workout cards will appear. So this is how JavaScript connects to the HTML page. So next, I create a function called render workouts. The purpose of this function is to display the current workouts on the page. So first, I clear the current content of the workout list. This is important because the function may run multiple times. Clearing it, the list prevents the duplicate workout cards. So next, I use for each loop to loop through the workouts array. The workout variable represents the current workout object. The index represents the position of that workout in the array. So next, for every workout, I create a new div element. Then I add the CSS class workout card. This class gives the card a border, padding, and a spacing. So next, I use inner HTML to add a content to the card. The heading displays the workout name. The paragraph displays the workout level. I also add a delete button. The $sign and curly braces allow me to insert JavaScript values into HTML string. So next, I will skip the delete button part. Let's go to the workout list. Finally, append child adds a completed card to the workout list container. This is the step that makes the workout card visible on the page. So here I add a submit event listener to the form. This function runs when the user clicks the add workout button. And normally submitting a form reloads the page. Event prevent default stops that default behavior. This allows JavaScript to process the form without refreshing the browser. Next, I create a JavaScript object called a new workout. The name property comes from the text input. I use trim to remove any extra spaces. The level property comes from the select menu. This object groups the workout information together. So here, I reset the form so the input. So here I use push to add the new workout object to the workouts array, and then do the reset to empty the input. Finally, I call render workouts. This reads the updated array and displays the workouts on the page. Now I will test the add feature. I will create a workout called leg day and select the beginner. When I click add a workout, the form submit event runs. JavaScript creates an object, adds it to the array, and then updates the DOM. I can also create like upper body. And now the array contains two objects, and the page displays two cards. So let's now talk about the delete button. Here, each card contains its own delete button, and I use query selector on the card to find that button. Then I add a click event listener. This function runs when the user clicks delete. And here, slice removes an item from the workouts array. The index tells JavaScript which workout should be removed. The number 1 means remove one item. After removing the workout from the array, I call render workouts again. This clears the old cards and displays the updated array. So you can see I click the delete on one of the workout cards. The workout is removed from the array. Then the page is rendered again, so the card disappears. This shows a common front-end pattern. First, we update the data, then we update the DOM so the interface matches the data. And after refresh, all of the workouts disappear. You can see after refresh, all of the workouts disappear. This happens because the data only existed inside the JavaScript array. The array was stored in memory, not in a database. So this demonstration used several important concepts from the course. HTML creates the form, inputs, button, and a container. JavaScript used a query selector to access the DOM. The submit and click events responded to user action. JavaScript objects stored the information for each workout. The array stored multiple workout objects. The render workouts function creates and updates the elements on the page. And the delete button changed the array and rendered the interface again. This example does not use a database, so the information is temporary. That's it.